everyone, welcome to Edupedia World. In today's lecture, we will discuss some general properties of salts and solve questions. General properties of salts. Salts are generally non-volatile ionic compounds having high melting and boiling points. Salts are either soluble or insoluble in water. The general rule concerning the solubility of salts in water is like this. The first rule says all nitrites and nitrates are soluble. The second rule says salts of sodium, potassium and ammonium are soluble. The third rule says all chlorides except AgCl, that is silver chloride, and Hg2Cl2 are soluble, and lead chloride, that is PbCl2, is soluble in hot water. PbCl2 is soluble in hot water. The next rule says, which is the fourth rule, it says all sulfates except CaSO4, BaSO4 and PbSO4 are soluble. The fifth rule says all carbonates, hydrogen carbonates, sulfides and sulfides except those of sodium, potassium and ammonium are insoluble. Exception: sodium, potassium and ammonium are insoluble. Now the next property is of electrical conductivity. Salts conduct electricity in aqueous solution or in molten state. Tap water containing dissolved salts which ionize in water, and hence tap water conducts electricity. But distilled water is a covalent compound and it does not contain any salt, and hence it does not contain electricity. Now, crystalline nature. Salts are either crystalline or amorphous. Many salts contain water of crystallization. The fixed number of water molecules which remain in the crystal lattice of crystalline salts are called water of crystallization. The water of crystallization is bonded to the parent molecule through coordinate bonds and hydrogen bonds. The water of crystallization can usually be removed from a crystalline salt by heating the salt at a temperature above 100 degrees Celsius. And when the crystalline salt loses its water of crystallization, it becomes amorphous. We can see this in a chemical reaction in which washing soda loses its water of crystallization, Na2CO3 dot 10H2. This is washing soda and it is crystalline. When it is heated at 373 Kelvin, it is losing 9 molecules of water. 9. So the product is Na2CO3.H2O. This is amorphous. This is amorphous. Now when it is again heated above 373 Kelvin, it will lose its water molecule and the product is Na2CO3. This is soda ash and it is amorphous. And the water of crystallization is often responsible for the color and crystalline nature of the salt. Now, some salts on exposure to atmosphere absorb moisture from the atmosphere dissolved in it and change into a liquid. Such salts are called deliquescent salts and the phenomenon is called deliquescence. The examples of deliquescent salts are CaCl2.6H2O, MgCl2.6H2O, Zn chloride, zinc chloride and FeCl3.6H2O. Now, hygroscopic substances. The substances which when exposed to the atmosphere at ordinary temperature absorb moisture from the atmosphere without dissolving in it are called hygroscopic substances. The examples of hygroscopic substances are CaO, H2SO4, P4O10, silica gel and ethyl alcohol. Now, efflorescence. Some crystalline hydrated salts on exposure to the atmosphere lose their water of crystallization partly or completely and change into amorphous powder. Such salts are called efflorescent salts and the phenomenon is called efflorescence. The examples are Na2CO3.10H2O, CuSO4.5H2O, MgSO4.7H2O and Na2SO4.10H2O. We can see this in a chemical reaction. Washing soda Na2CO3.10H2O, when it loses its water of crystallization, Na2CO3.H2O plus 9H2O. This is crystalline and this is amorphous. We can see another example also. CuSO4.5H2O. This is blue in color and crystalline in nature. When this will lose its moisture, water, then CuSO4.thrice-H2O, which is pale blue in color and amorphous in nature, along with 2 molecules of water is formed. Now, the next property is hydrolysis. The phenomenon of the interaction of cations and anions of a salt with H positive and OH negative ions of water is called hydrolysis. The hydrolysis of a salt obtained by the reaction of a strong acid and a weak base produces weak acidic solution. Let's take an example. Ammonium chloride is obtained by the reaction of strong acid, that is HCl. It is strong acid. When it reacts with NH4OH, NH4OH, this is weak base. So ammonium chloride, that is NH4Cl, is formed along with water. So solution of NH4Cl in water is weakly acidic. There are other examples of salts which form acidic solution on hydrolysis. Acidic solution on hydrolysis. Those salts are ammonium nitrate, NH4NO3. This is ammonium nitrate. The next salt is ammonium sulfate. Chemical formula is NH4,2SO4. This is ammonium sulfate. The next example is copper chloride, CuCl2. Copper chloride. The another example is copper sulfate, CuSO4. Copper sulfate. So depending on the nature of salts, it is classified into 4 types. The first type says hydrolysis of salts of strong acids and weak bases. This type of hydrolysis produces a strong acid which ionizes. It will produce strong acid which ionizes and a weak base, which does not ionize. This increases the concentration of H positive ion, making the solution acidic. The solution will be acidic and has a pH less than 7. Examples of strong acid and a weak base are NH4 twice SO4, CuSO4, NH4 NO3 and FeCl3. Example is hydrolysis of copper sulfate. Hydrolysis of CuSO4. So we can see in chemical reaction Cu2 positive, when it reacts with sulfate ion SO4 twice negative along with 2 molecules of water, it will produce CuOH whole twice H positive and sulfate ion SO4 2 negative. As only the cation of salts reacts with water, it is also called cationic hydrolysis. The next hydrolysis is hydrolysis of salts of weak acids and strong bases. This produces a weak acid which does not ionize and a strong base which ionizes and give OH negative ion. And the solution is basic, having pH more than 7. And examples of weak acid and strong base are Na2CO3, CH3, COOK, and CH3COONA. And the chemical reaction is like this. We will see hydrolysis of CH3 COONA. The chemical reaction is like this: CH3 COO negative along with Na positive and water molecule. This will lead to CH3 COOH and Na positive and OH negative. As the anion of the salt reacts with water, it is also called anionic hydrolysis. The another type is, which is the third type, is hydrolysis of salts of strong acids and weak bases. This type of hydrolysis produces a strong acid and a strong base which are completely ionized, giving equal number of H positive and OH negative ion. Hence the solution is neutral with a pH of 7. The example is hydrolysis of sodium chloride, NaCl. Na positive and Cl negative reacts with water and will produce Na positive, OH negative, H positive and Cl negative. The another type is, which is the fourth type, is hydrolysis of salts of weak acids and weak bases. This produces a weak acid and a weak base which exist in the molecular form. Thus there are no free H positive or OH negative ions, and the solution is neutral with pH equal to 7. And the examples of salts of weak acid and weak bases are NH4 twice CO3 and CH3 COONH4. Example is hydrolysis of NH4 twice CO3. Twice NH4 positive when it reacts with CO3 twice negative along with 2 molecules of water will lead twice NH4OH along with H2CO3. So these are the classification of salt hydrolysis. Now we will discuss some salt questions. Question number 1 is, what happens when electric current is passed through brine and give chemical reaction? The solution is, when electric current is passed through a concentrated aqueous solution of sodium chloride or brine, sodium chloride decomposes to give sodium hydroxide, which is formed near the cathode, and the other product of electrolysis are chlorine and hydrogen. Chlorine gas is evolved at the anode and hydrogen gas is given off at the cathode. The chemical reaction will be like this: twice NaCl when it reacts with 2 molecules of water. This is aqueous and this is liquid. It will give twice NaOH, which is aqueous, along with chlorine, which is gaseous, and hydrogen is also gaseous. So sodium hydroxide is formed near the cathode and other products of electrolysis are chlorine and hydrogen. Chlorine gas is evolved at anode and hydrogen gas is given off at the cathode. Now next question is, why is the Solvay process considered economical? Solvay process is economical because the chemical produced can be reused in the process. For example, calcium oxide formed by the thermal decomposition of limestone is converted into slate lime. In this chemical reaction, CaCO3, when heat is applied to it, it will form CaO along with CO2. So calcium oxide, that is slate lime, is formed, which is then reacted with ammonium chloride to form ammonia and calcium chloride. The byproduct obtained in the process is calcium chloride, which is sold to recover part of the cost of the process. Hence the process is considered to be economical. So when CaO reacts with water, calcium CaOH whole twice is formed, and when this is reacted with twice NH4Cl, it will produce calcium chloride along with 2 molecules of water and twice NH3. So the chemical produced are reused in the process. So this process is considered to be economical. Now the next question. Question number 3. Plaster of Paris should be stored in a moisture-proof container. Explain why. The solution is, when plaster of Paris comes in contact with moisture, it is converted into gypsum and a solid mass is obtained, which cannot be used as a plaster. Hence, plaster of Paris is always stored in a moisture-proof container. The next question, that is question number 4. Excessive use of nitrogenous fertilizer may lead to water pollution. Explain. Solution is, the nitrogenous fertilizer such as ammonium sulfate undergoes hydrolysis under the acidic condition of the soil to form sulfuric acid and ammonium hydroxide. As a result, the acidity of soil and water above the soil decreases. Both H2SO4 and NH4OH are not desirable in water, and the chemical reaction which occur is like this: twice NH4 to SO4 when it reacts with 4 molecules of water and pH is maintained between 5.5 to 6.9, twice H2SO4 along with 4 molecules of NH4OH, and H2SO4 and NH4OH are both undesirable. Thus the pollution in water increases. The nitrogenous fertilizer urea does not produce acidic hydrolysis products and is therefore more desirable. Hence, excessive use of nitrogenous fertilizer may lead to water pollution. Thank you for watching Edupedia World Videos.